Now I'm happy to talk about, I think, the product with the coolest name, being Ripple. And you see Ripple 8, Ripple 16, which of course is an antenna that we've constructed, made for our maritime partners and their customers. So in short, a little bit, the Maritime Antennas, last 4 years, we sold about more than 15,000 maritime antennas. But it even goes back further, because our first antenna, maritime antenna, only was created in 2016. That was the Omni 291. But before that time, our antennas were already installed on vessels everywhere in the world. We sometimes still discover Omni 69s on vessels that are still alive. So great, even when they were not seaworthy, as we would say. So starting from the Omni 291 in 2016, we've of course implemented all the necessary parameters to be seaworthy, like IP68, UV, salt waterproof, etc. Those things you need on a vessel, of course. So the Ripple positioning, you see the very nice shape and design of the Ripple. So where do we position the Ripple? Of course, it was the missing link between the already existing product range on maritime antennas we have, and we do have quite some antennas there, which all have different applications, of course, or same applications. Now, about 2 years ago, we've presented our prototype Wave Hunter, which is already out there and performing really well. We get really nice feedback and results on that. Now, the idea about the dome solution in maritime world is, of course, increasing system reliability on transmission, enhanced LTE and 5G reception, which is, of course, more and more crucial as we see more and more connectivity challenges and demand for higher bandwidth. It's of course created for harsh environments, because we all know that the sea is not forgiving. So it's very harsh environments, salt, UV, water. It can be quite stormy out there. So it needs to be really protected against these environments. And of course, there are different marine applications. We can go for super yachts, commercial vessels, cruise ships, ferries, expedition yachts, offshore vessels, even buoys. And then we should think about not the small red round things floating in the sea, but you have these buoys that have cameras on there. They monitor every changes in wind speeds, storm, also security cameras for offshore wind farms, for example, harbor buildings. So everywhere where there's demand of higher bandwidth, it is applicable. So why Ripple? Of course, what we have seen also in the maritime market, that there's more and more demand for higher bandwidth. A nice catalyst for this was, of course, COVID, where we saw that people had to stay on the vessels for very long times, missing friends, family, etc. So that's one thing where IMO, the International Maritime Organization, decided to create a maritime law that a minimal internet should be available for the crew, the crew welfare. So that really is a catalyst. So people are really looking at more resilient, more stable, and higher bandwidth solutions on 4G, 5G, and other solutions, of course. So we create bandwidth and a higher bandwidth solution within an IP65 enclosure, of course. Flexible solution on cable management, because we all seen the introduction from 4G, from 5G. We went the evolution from 4G to 5G. And this, of course, meant from going from 2 antennas to 4 antennas. Now imagine that what I've seen from the last year's installations, that more and more of these standard installations go to dual 5G, 5G meaning 4 antennas, dual 5G meaning 8 antennas. Imagine pulling cables over 10 to 15 meters, but then times 8. It's not only expensive, but also very time consuming. And of course, we all know that long coaxial cables will induce more loss than, of course, short coaxial cables. So we also, one of the key selling points is that it's high bandwidth within a budget-friendly solution, which means it will cost money, but the total solution will not be that more expensive. We have some comparison charts on normal antennas with cables, time consuming, and a Ripple with all the antennas inside. So we are happy to discuss that. We're of course brand agnostic. That means you can set up any kind of brand or router combination inside the Ripple, which of course makes it all again a lot more flexible, because well, you can really combine every kind of router, because per application you can have a separate or a different combination of routers inside, of course, depending on the application. Now, what of course we do, we combine our patented superior radiation patterns. It came up in the presentation of Sophia and Hugo. It's something you now expect from us, that we shape patterns, radiation patterns, because those really give a clear view on how the antenna will focus its energy and where that fantastic gain you see sometimes is really going to, because you need to know what is this antenna doing. Now, of course, we are here talking about a maritime antenna, an antenna that will go on a moving object, meaning a vessel. Well, of course, here we have the benefit of really being experienced and creating a really consistent omnidirectional radiation pattern, which has a really even gain in a 360-degree view, which is very important on a moving object. And what we've, of course, implemented out of our vast on-land experience, and also the experience we have from WaveHunter, is the effect of cross-polarization. Cross-polarization is really a technique that anticipates on what happens out there when the electromagnetic waves are traveling from the cell tower towards the receiving object, in this case, the vessel. So it's a technique we use to double the bandwidth. And that's really a quote from, I could quote our CEO: the moment you're 3 kilometers from the cell tower, this will double your bandwidth compared to a normal vertically polarized or horizontal polarized stick antenna. So that's really simple technique we apply, patented of course, to double the bandwidth of the signal using the signal that's out there. So we have electrical features. So we are talking about peak gains of 2 different setups, because why? We offer a 4 times 4x4 MIMO, so you can really have 4 5G modems in there. We have 8 vertical and 8 horizontal antennas. Yeah. So we have the cross polarization. Ripple 8 will have half of the antennas. Ripple 16, the 4x4, the 4 times 4x4. Ripple 8, the 2 times 4x4. Cross polarization will increase signal reliability and double data rate due to the full MIMO performance. That's what we already discussed. Covers the contemporary 5G LTE bands from 617, the band 71, which is already used in US and South America, and will probably come to the rest of the world too, up to 7,200 megahertz, and then we're talking Wi-Fi 6E. It has 2 GPSs inside, GLONASS Galileo, so we'll work with the 3 different systems. And of course, it has a high performance, and this is the difference between WaveHunter and Ripple. Here we use omnidirectional antennas to create the array inside the Ripple. And it's of course marine and coastal. We have of course 2 different peak gains, as you see. The vertical antennas do have 9.5 dBis of gain, and the horizontals will have 3 dBis of gain. So mechanical features, of course, it's UV and salt waterproof, else you don't have any business on a vessel. It's protected from marine and coastal conditions, so it should protect those routers inside very well. It is IP65, weather dust resistant enclosure, and it has a very innovative heat sink that is designed to really improve the temperature regulation inside. As we all know that 5G modems will produce a little bit more heat than 4G modems. And it also has wind survival up to plus minus 186 kilometers, which is quite a storm, I guess. So Ripple 16 and thus also Ripple 8. It's a circular array of omnidirectional antennas that operates in the following frequency bands. Here in the picture you can see 617 to 960 megahertz, 1427 to 1517, 1710 to 2700, and then 3400 up to 6000 megahertz, and the 4 times dual band Wi-Fi up to Wi-Fi 6E, meaning 7200 megahertz. And of course, it's always nice to see Ripple measured results in the comparison to a lot of brands, also really renowned brands. We do measure our results. Everything you see in our technical documents are measured results and not simulated results. And this is something we see a lot, but it is very hard to compare simulated results in real life. So we give measured results and honest results. What you see is what you get. So you see the Ripple here inside, you see a router compartment where you can fit in the routers. So to our radiation patterns, again, what you see, always what you need to look at is VSWR on a certain frequency and the gain, of course. That's where you need to look. What does this antenna mean for my application? What we always say, try to keep the VSWR below 2.5, better 2 or less. So you can really see that it's almost 95% below 2, which is awesome. And the gain on the vertical, we are here talking about the vertical antennas. You see it's really consistent, and it's a peak gain of about 9.5. And depending on the frequency, of course, but I should not explain, there can be a difference, which is normal. Cellular horizontal VSWR, again, you see 95% below 2, which is awesome again. And then the 3 dBi max gain on the horizontal antennas, as we mentioned, you can also see in the gain graph. Then the radiation patterns, looking azimuth. This is what you should expect from Poynting, which we are really great in shaping those radiation patterns. And as we are talking about moving object, of course, the omnidirectionality is really key. And this is something we are really good at. You can just see it. The outer circle is the max gain that we put in our spec sheets, but you see that this radiation pattern shows that you're really close the whole time when you look at the 360 view to our max gain that we describe in the technical sheet. Really consistent signal reception, which will give, of course, the router a really consistent signal to work with and do all its features. On the elevation part, this is, of course, something we've been explaining in our maritime webinars also. It is very good to have a very nice vertical aperture on a maritime antenna. Why? Well, the sea is practically never a mirror, so there will always be some kind of waves. So a very nice vertical aperture will avoid you shooting over and under the cell tower with your antenna when there are quite some waves at sea. And when you go too high a bandwidth, your vertical aperture will be very narrow. And the moment the smallest wave hits your vessel, you will shoot over and under the cell tower. So you need to avoid it. But you see here in our antennas, a very nice vertical aperture. So azimuth on the horizontal, again, very nice, consistent omnidirectional, as you see. And then going to the elevation, again, very nice elevation, vertical aperture, which will keep that consistent connection with the cell towers, even when it gets a little bit more rough out at sea. So Ripple mounting options, it's a surface mounting antenna, but most integrators that work in the maritime world, of course, know that how they can install it, probably somewhere on a pedestal, already existing pedestal of an old VSAT, or maybe a new one they create in a local metal shop in the harbor, or to put the Ripple on there. You see maybe the height, so it's about 41 centimeters in diameter, so it's not that big, and it's almost 50 centimeters high. So it's quite quite small for a dome solution on a vessel, if you compare it to the bigger VSATs, etc. Here a little bit the comparison, the key features between Ripple and WaveHunter. And I must say we are having a maritime webinar on this Thursday, will be done by Hugo, where we go more in depth on the differences here. And this will really explain more when to choose what. And I hope you can follow that too, because we really share some valuable information on this. Now, going over this, Ripple 16, whether it's 18 or 8, Ripple 8 or 16, compared to WaveHunter, what you see, Ripple 16 has 8 vertical ports, 8 vertical antennas, and 8 horizontal ports or antennas. Compared to, of course, where we work with WaveHunter is in 6 sectors with 4 polarizations, vertical, horizontal, plus and minus 45. MIMO, it's a 4 times the possibility of the 4 times 4x4 MIMO setup. So you can combine a maximum of 4 5G modems in there. And on Wi-Fi, you also have 4x4 MIMO Wi-Fi. Ripple, of course, has 6 times 4x4 LTE. The frequency bands 617 to 4200. The Wi-Fi 2.4, 5.6, and 7.2. And of course, GPS is in there too. Those frequencies are known. And then the same frequencies for WaveHunter. So there's no difference there. Those frequencies are covered. Polarization with the Ripple is vertical, horizontal. And in WaveHunter, we have 4 polarizations. The peak gain, there you see the biggest difference. You have 9.5 dBi max gain on the vertical antennas and 3 dBi on the horizontal, where you have 11 dBi on the WaveHunter antennas, the max gain. Connector types, we've introduced right angle SMA and right angle RP SMA for the Wi-Fi. So in total, there will be 18 normal SMAs and 4 RP SMAs. So we've introduced right angle. Why? We've had very valuable feedback from the system integrators that it would be more practical to have right angle. So we implemented that. And of course, we implement all the cables through the coaxial cables. And this is where it's really a difference, because this is such a time saver. Imagine an integrator crimping cables at length and then times what you see here is 22, and then needing to crimp them, put the connectors on there, sizing them, and then still installing them on a vessel, running them through cable glands. So you cannot imagine how much hours you lose on doing this. So it's a real time saver. The cables are just in there, you connect them to the modems, and done deal. The same, of course, with WaveHunter, where we've evolved. The V2 version didn't have any cables yet. Starting from the V3 version, we've implemented the 30 cables inside, so you can simply connect it to the routers. No more cable measuring or a crimping of connectors. It's all in there. Mounting options, both are surface mount or on a pedestal. Weight and dimensions, this is also a big difference, of course. You see the 51 kilograms of the WaveHunter, and you see the 15.44 kilograms of Ripple, which means that, let's say you have 2 people installing it, you could easily get this up there without a crane. It's only 15 kilograms. And then maybe another guy hold it down when you screw it on there. But it's really flexible, and you do not need a crane to put it on the vessel. Packaged weights, of course, and the EN codes will all be in this technical sheets, so you will be able to implement it in your systems. So, big difference, Ripple WaveHunter. This is something which will be explained much more in depth about Hugo this Thursday. So, of course, in a Ripple, you can combine 4 5G modems, and in a WaveHunter, you will have 6 5G modems. That means you can combine, you aggregate the bandwidth of 4 5G modems compared to 6 5G modems. There you can make a difference in bandwidth, of course. The WaveHunter will reach further because of its higher gain, of course. It uses directional antennas with higher gain than the omnidirectional antennas that are in Ripple. Wave Hunter also has a superior signal to noise ratio. Why? Of course, it is inherent to the use of a directional antenna that it only looks in one direction, so it could only catch noise from one direction. And compared to an omnidirectional antenna, which looks 360 degrees, it can of course see noise from everywhere. So Wave Hunter will have a better signal to noise ratio because of the directional antennas inside. And then Ripple at 8 or 16 is much more budget friendly, and this is where we really had a very good feedback at SMM Hamburg in September 2022, the biggest commercial maritime show in Europe, probably in the world, where the integrators really said, okay, we can work with that, with this price point and the time saving, and of course the quality of the product. We can really work with this in the commercial maritime market. And we also had this feedback from shipping companies that it's really acceptable for this solution to have it. Thank you.